As the competition over generative artificial intelligence, AI intensifies, companies are spending enormous amounts of money securing semiconductors for data centers. That is because faster AI requires the latest semiconductors and servers. Accordingly, instead of endlessly producing fresh hardware, moves are surfacing to make use of the processing power found in devices already built. As this approach recycles a device's own capabilities, it is emerging as a novel type of digital recycling. Recycling functions. The term digital recycling does not yet have a completely agreed-upon definition in industry or academia. Recently, however, there has been growing interest in using the functions of devices such as smartphones and computers for other purposes, thereby extending their useful lives. Rather than conventional recycling, which breaks products down into raw materials, this approach is closer to reuse or repurposing. The idea is to make use of a device's computing, storage, and communication functions first, and recover its raw materials only when it can no longer operate. Urban mining. Recovering metals from discarded electronic products is often called urban mining. The circuit boards of smartphones and computers contain various metals, including gold, silver, and copper. In urban mining, collected electronic products are dismantled and crushed, and then the metals are extracted by melting them at high temperatures or using chemical solutions. Urban mining, however, is unable to retain a product's functions. Even when a semiconductor remains functional, its processing capability is lost as soon as the circuit board gets crushed. Recovering the metals and using them to manufacture new semiconductors likewise requires substantial energy and money. In addition, the costs and risks of processing electronic waste are not distributed equally around the world. Some electronic waste discarded in developed countries is transported to developing countries. In places without proper facilities or protective equipment, workers can be exposed to toxic gases and heavy metals. That is why urban mining is necessary as the final stage of recycling. But immediately crushing devices that still work is not always the best choice. What makes more sense is reusing their functions first, so they last longer, before safely reclaiming their metals at specialist plants, only once they've truly stopped being useful. A supplementary solution in the age of chipflation. Chipflation is one factor behind the growing interest in digital recycling. The term fuses chip and inflation to capture how prices for chips and related products are rising alongside surging semiconductor demand. Only a small handful of companies, notably, can manufacture advanced AI semiconductors, and expanding their production facilities demands enormous amounts of time and money. However, discarded smartphones cannot simply replace the latest AI semiconductors. Training massive AI models requires extremely high-performance semiconductors and communication networks, which smartphone chips cannot handle. On the other hand, lighter tasks, such as educational programs or simple data analysis, can be processed by systems that connect multiple smartphones. By dividing tasks according to what existing devices can handle, high-performance semiconductors can be reserved for jobs that truly require them. Digital recycling is a proposal to view discarded devices not simply as sources of raw materials, but as computers that may still have useful work to do.